So hi everyone, and let's get started. So in today's tutorial, we'll be talking about power of trade and comparative advantage. So as usual, we will go through some key concepts in this topic before we delve into the main discussion questions, example question and past example questions. And by the end of the tutorial, we'll also complete the attendance exercise. So let's start with reviewing the meaning of absolute advantage and comparative advantage first. When we say that a person has absolute advantage in production, it means that it can produce a larger amount of output than the other person with the same amount of resources. And in other words, when you have an absolute advantage in production, then you have a higher productivity than the other person in producing this good. So this is the meaning of absolute advantage. While for comparative advantage, when we say that you have a comparative advantage in production, this means that you can forego a small amount of another good than the other person in producing the same amount of the good. And in other words, you have a lower opportunity cost in producing the good than the other person when you have comparative advantage in producing this good. And at the end, we also have the principle of comparative advantage, which is saying that everyone does the best when each person specializes in producing the good in which it enjoys a comparative advantage in production. So let me go through the following motivation example to show what I exactly mean about these concepts. Okay, so this table here is illustrating the production of Annie and Benny per unit of resources. So we are going to determine who has the absolute advantage in producing food and clothing respectively in the first part here. Okay, so let's consider food production first. So given 1 unit of resources, Annie can produce 5 units of food, while Benny can only produce 3 units of food. And since 5 is greater than 3, this means that Annie can produce more units of food than Benny with the same amount of resources. But this means that Annie has an absolute advantage in producing food. Okay, so how about clothing production? So given 1 unit of resources, Annie can produce 4 units of clothing, while Benny can only produce 1 unit of clothing. And again, 4 is greater than 1, then this means that with the same amount of resources, Annie can produce more clothing than Benny. Right? Annie is having an absolute advantage in producing clothing because she is more productive in clothing production. Okay, so this is how we can determine who has the absolute advantage in production. And the second part here is to determine who has the comparative advantage in food and clothing production respectively. So as you may notice, we need to construct an opportunity cost table to determine this information. Okay, so let's say from the perspective of Annie, given 1 unit of resources, she can either use it to produce 5 units of F or 4 units of C. Okay, so in other words, 5F is kind of equivalent to 4C from the perspective of Annie. So this is how we can construct the opportunity cost relationship for Annie. 5F equals to 4C. And if we divide both sides by 5, then we'll have 1F equals to 4 over 5C. Or if we divide both sides by 4, then we have 1C equals to 5 over 4F. And this essentially the information that I've put down about Annie. All right, so we do something similar from the perspective of Benny. Given 1 unit of resources, Benny can either use it to produce 3 units of food or 1 unit of clothing. So in some sense, 3F is equivalent to 1C from the perspective of Benny. And if we divide both sides by 3, then we'll have 1F equals to 1 over 3C. And this is essentially the information that I've put down for the row of Benny here. And this is how we can construct the opportunity cost table here. Right, so we are now ready to compare the opportunity cost of production. So let's start with food production first. For Annie, okay, it requires 4 over 5C, while for Benny, it requires 1 over 3C to produce 1 unit of food, right? And obviously 1 over 3 is more than 4 over 5. This means that Benny has a lower opportunity cost in food production, and thus a comparative advantage in producing food. All right, so how about clothing production? Annie requires 5 over 4F to produce 1 unit of clothing, while Benny requires 3F to produce 1 unit of clothing. Since 5 over 4 is more than 3, then this means that Annie has a lower opportunity cost in producing clothing, and thus a comparative advantage in producing clothing. So this is how we can determine who has the comparative advantage in production. All right, so here I have 3 remarks to sum up this motivation example. So the first one is saying that it is possible that a person has absolute advantages in producing all goods over another person. So this first remark is actually illustrated by the first part of this motivation example. So as far as the person is really very productive, right, Annie in this case, then this person can have absolute advantage in producing all goods. But the second remark is saying that it is impossible that a person has comparative advantages in producing both goods over another person. And if it has a comparative advantage in producing a good, then this person must have a comparative disadvantage in producing the other good. So let me go back to the second part here to illustrate what I exactly mean about the last 2 remarks. So instead of using the numbers here, let me make up some random numbers. Okay, let's say the opportunity cost of producing 1F for Annie is XC, while that for Benny is YC. Okay, just some random numbers to illustrate the idea. So we know that the opportunity cost of producing 1 unit of clothing for Annie will be 1 over XF, while for Benny it will be 1 over YF, right? The reciprocal. Okay, so further assume that Benny has a comparative advantage in food production. This means that he has a lower opportunity cost in producing food, and this means that X will be greater than Y. Okay, so by some properties of inequalities and both X and Y are positive, then we must have the case that 1 over X is smaller than 1 over Y, which means that Annie has a lower opportunity cost in producing clothing than Benny, right? So from this, we know that a person cannot have comparative advantage in producing all goods. All right, so this is about the remarks here. And the next concept to review is about term of trade, and it is the relative price of a traded good in terms of another good. So the remark is saying that a term of trade is mutually beneficial when it strictly lies between the unit production costs of the trading parties. So again, let me go back here to illustrate the idea. All right, so let me say the term of trade is now 1C equals to 2F. Okay, 2 is just a random number between 5 over 4 and 3. Okay, just a random number between these 2 values. So what will be the gain for Benny and Annie in this case? So we know that Annie is the one who produced clothing, right? So for each unit of clothing she trade, she will receive 2F and requiring 5 over 4F of production costs, right? So this means that in some sense, Annie is gaining 2 minus 5 over 4 units of F per unit of clothing traded. While for Benny, he is the one who buys clothing. So if he is producing clothing himself, it requires 3F of production costs. While if he trades with Annie, it requires only 2F, right? The term of trade. So in some sense, for each unit of clothing traded, Benny can save 3 minus 2, which is 1 unit of F per unit of clothing traded. And obviously, both Annie and Benny will receive positive gains from trade, as far as the term of trade is strictly between the unit opportunity cost of production. All right. And finally here, the unit gain from trading a good is determined by the difference between the opportunity cost of the 2 trading parties. The larger the difference is, the greater the unit gain. If we're trying to calculate the unit gain from trading a good, we are actually summing up the individual gains of the 2 trading parties here. Okay, sum up these 2 things. And in net, we will have 3 minus 5 over 4F per unit of clothing traded. Okay, 3 minus 5 over 4F is the gains from trading 1 unit of clothing. So how can you interpret the numbers here? 3 and 5 over 4 is actually the production cost of Annie and Benny, right? So this exactly illustrates the bullet point that I've just mentioned. All right, so finally, to review about the production possibilities curve and consumption possibilities curve. So for production possibilities curve, it traces all efficiently produced level of goods, and graphically, it would kink outwards. Okay, so an example of production possibilities curve will be something like this. Well, for consumption possibilities curve, it will divide into two cases. In a closed economy where people have to consume what they produce, then consumption possibilities would equal to production possibilities. Okay, the same yellow cane curve here. But in an open economy, it is more likely that consumption possibilities is greater than production possibilities because people in the economy can trade with others in the world, right? In the world market. Let me draw it again. Right, so this blue line here will be an example of consumption possibilities curve in an open economy. And by the way, the slope of this blue line is actually the negative of the price ratio between the two goods in the world market. And the blue line need not intersect the PBC at the king point if the slope of the CPC is flat. Right? It could happen to intersect the PBC at the y-intercept, while if the CPC is steep, then it could happen to intersect the PBC at the x-intercept. And anyway, to find out the position of consumption possibilities curve, it is essentially to apply the technique of linear programming to find the outest point of the PBC with the negative of the price ratio as a slope. All right, so that's all I would like to review for this topic, and I'll give you some time to glance through this problem before I go into the explanations. And again, if you have any question, you can feel free to raise up. For this problem, question 1 is actually talking about trading in a closed economy, while question 2 is actually about trading in an open economy. So I'd like to explain the questions in detail so that you can understand the difference in the method in solving the question type. Okay, so let me start with question 1. So they would like to jointly consume banana and coconut at a ratio of 7 to 11. What will be the banana production and coconut production respectively? So I introduced two methods to solve question 1. First method is to solve it by hand mathematically, while method 2 is to use GeoGebra, the mathematical software, to help us deal with this problem. Okay, so either methods, we need to construct an opportunity cost table to determine who has the comparative advantage in producing each good. So by the way, the table here is essentially the information at the beginning here. I just transform it in a tabular form. Okay, so from the perspective of Paul, given 1 week, he can either produce 3 units of banana or 2 units of coconut. So we have the opportunity cost relationship for Paul. And essentially, if we divide both sides by 3, then we have 1b equals to 2 over 3c, or 1c equals to 3 over 2b. And this is the information in the row of Paul. And similarly, from a perspective of Mary, given 1 week, she can either produce 4 banana or 6 coconuts. So we have the opportunity cost relationship for Mary. So divide both sides by 4, we have 1b equals to 3 over 2c, or divide both sides by 6, we have 1c equals to 2 over 3b. And this is the information in the role of Mary here. And we are now ready to determine who has the comparative advantage in production. So for banana, since 2/3 is more than 3/2, then Paul has the comparative advantage in producing banana. While for coconut, since 2/3 is more than 3/2, then Mary has a comparative advantage in producing coconut. All right, so at this point of complete specialization, Paul will be producing 3 kgs of banana, while Mary will be producing 6 kgs of coconut. Okay, so this is why at the point of complete specialization, we'll have banana to coconut ratio is 3:6, or effectively 1:2. Okay, so in the coordinate form, we will have banana and coconut to be 3:6. All right. However, the target in this question is to have banana to coconut at a ratio of 7:11. This means that Mary needs to sacrifice some of her time to produce banana and less of coconut. Okay, so let's start with the point of complete specialization, where there is 3 units of banana and 6 units of coconut. And here we let B to be the amount of banana that Mary should produce. Okay, then in total, they will have 3 plus B units of banana. How about coconut? It will be reduced by a certain number, which is 3/2 times B. So 3/2 actually comes from here. Let me highlight a number for you. 3/2 actually comes from here, the opportunity cost of producing 1 unit of banana for Mary. Okay, so here the ratio should be equal to 7/11 to attain the desired ratio. And here there's only one unknown B, then we are able to solve it out, which is 0.42. And finally, the banana production will be 3 plus B, and the coconut production will be 6 minus 3/2 times B, and we will have the result. And I hope you actually realize that this method is quite tedious. And this is why I would like to introduce the second method using the mathematical software GeoGebra to help us complete the problem more handily. Okay, so at this point of time, let me shift my screen to GeoGebra. All right, so you can see the slide and also GeoGebra. So the idea to use GeoGebra is that if we're able to plot a PBC, something like this, and also the desired ratio, then the intersection between the PBC and the desired ratio is essentially the answer to this problem. And this is the intuition of using GeoGebra to complete the problem. Okay, so to construct a production possibilities curve, we actually need the x-intercept, y-intercept, and also the king point. So this is what we will do in the first 2 steps here. Okay, so if I'm plotting banana on the x-axis while coconut on the y-axis, the x-intercept simply means that what is their banana production if both of them only produce banana. Okay, if both of them only produce banana, they will have 3 plus 4 kgs of banana. Okay, so the x-intercept is 7. While for the y-intercept, it means that if they only produce coconut, what would it be their coconut production? So it will be 2 plus 6, which is 8. The y-intercept is 8. So this is how we can complete step 1 to find the x-intercept and the y-intercept of the PBC. All right, so step 2 now, find the king point using the opportunity cost table. So I've just mentioned here, right? Banana and coconut at the point of complete specialization is 3:6. So this is the king point. All right, so we have the 3 key points of the PBC right now. And we move on to step 3, which is to use a fancy function in GeoGebra to help us connect the 3 points here. So we will use the tools here, click tools, scroll down a bit, and you should be able to find something called segment. What you need to do is just to click the 2 points, and then GeoGebra will help you connect the 2 points. Okay, do the same for here. And this is how we can obtain the PBC. All right, so finally, we'll move on to step 4 to draw a line that illustrates the desired consumption ratio. because we know that banana to coconut is in the ratio of 7 to 11. Okay, so essentially it will be B over C equals to 7 over 11. And since banana is on the x-axis while coconut is on the y-axis, so this is why we are trying to draw a line x over y equals to 7 over 11 to illustrate the desired ratio. All right, so this is how we can plot the graph in GeoGebra. And intersection between the PBC and the green line here will give us the result. Right, so banana production is 3.42, while coconut production is 5.37. The result as put down here. Okay, so hope you can appreciate the method of using GeoGebra to tackle this part. Okay, so let me go back to the slide and continue question 2. Okay, now we are talking about trading in an open economy where they would like to jointly consume 5 kgs of banana, and we have the world price of coconut $1 and the price of banana $2. What will be the coconut consumption for them? So we actually also have 2 steps to follow from for question 2. So step 1 is to find the maximum income that each of them could earn, while step 2 is to find the total income and observe how they could spend on the goods. Okay, so let's say for Paul, if he is producing banana, he can earn 3 kg of banana multiplied by $2, which is $6. Or if he is producing coconut, he can produce 2 kgs multiplied by $1 to earn $2. And obviously 6 is greater than 2, then Paul would produce bananas to earn $6. All right, so on the same token, for Mary, if she's producing banana, she can earn 4 times 2, which is 8, or to produce coconut and earn 6 times 1, which is 6. And since 8 is greater than 6, then Mary will spend all her time to produce banana and earn $8. All right, so this is step 1. And then we move on to step 2. We know that their total income would be $14, and their desired banana consumption is 5 kg. So they will spend 2 times 5, which is $10 on banana consumption. So they have $4 remaining, and they can spend the remaining $4 on coconut. Since coconut costs $1 per kg, then they will be consuming $4 divided by $1, which is 4 kgs in total. All right, so this is how we can solve question 2. And yeah, so please take a look at this problem before I go into explanations. Okay, so let me start with question 13 to find the opportunity cost for Chris to produce 1 kg of tea, and also the opportunity cost for Dana in producing 1 unit of tea. So the only numbers given in the question is about the slope of AB and the slope of BC, right? So it's also the information I put down here. So how can we interpret the slope coefficients here? So recall your high school mathematics knowledge. So slope can be calculated as delta y over delta x. Okay, so let's say for the line segment AB, the slope of negative 1.6 simply means that if you produce tea production by 1 unit, your banana production would be reduced by 1.6 units. So this is the interpretation of this number. And from here, it is actually the opportunity cost relationship, right? If you produce 1 more unit of tea, then you would forego your banana production by 1.6 B. So this is how we can construct the opportunity cost relationship from the slope coefficient. Okay. On the similar token, for the line segment BC with the slope negative 3.5, it means that when you increase your tea production by 1 unit, you have to forego your banana production by 3.5 units. So this is how we can get 1T equals to 3.5 B. Okay, what remains is to map these two opportunity cost relationship back to Chris and Dana respectively. So from the question here, we know that Chris has the comparative advantage in producing tea, which means that Chris has a lower opportunity cost in producing tea. Okay, so this is why 1T equals to 1.6 B. Okay, the small number will be mapped to Chris. Right, and the remaining one will be mapped to Dana. So this is for question 13. And how about question 14? What would Chris and Dana produce respectively? So be aware, we are talking about trading in an open economy here, right? We have the world price of tea and world price of banana to be the same. This means the two cost relationship will be 1T equals to 1B in the world market. Okay, so we will use this to compare with their opportunity cost of production. Let's say for Chris, his opportunity cost relationship is 1T equals to 1.6B, or equivalently, 1B equals to 1 over 1.6T. Okay, so obviously, 1 over 1.6 is smaller than 1. And this is why Chris has a low opportunity cost in producing banana compared with the world trade ratio. And this is why Chris should produce banana. And from the perspective of Dana, we do something similar. Her opportunity cost of production is 1T equals to 3.5B, or equivalently, 1B equals to 1 over 3.5T. And since 1 over 3.5 is more than 1, then Dana will be producing banana, okay, when compared with the world trade ratio. Okay, so this is how we can complete the problem here. So please take a look at this problem before I go into the explanations. Okay, so let me start explaining this problem. So question 5, 1 standard maintenance services include 1 clutch replacement and 2 brake replacement. So if they work separately, what would be the total number of standard maintenance services that they can produce? So actually, we have the individual PBC given here. If we can plot the desired ratio of a brake to clutch equals to 2 over 1, then we just need to find the intersection between the desired ratio and the individual PBC to obtain the answer for question 5. Okay, so this is the idea. And let me shift the screen to GeoGebra to solve this problem with you together. Right, so here, GeoGebra. We actually have the information of the individual PBC. Right, we have the x-intercept and the y-intercept. Right? So let's say for Stephen, the x-intercept is 54, while the y-intercept is 143. So let's start with Stephen first. So we just type the x and y coordinate here. Okay, so now we will have the points, okay, the 2 points, the x and y-intercept of Stephen's individual PBC. So we just need to use the segment function that I've just introduced to you to connect these 2 points. And then the next step is to draw the desired ratio, B over C equals to 2 over 1. Because brake is on the x-axis while clutch is on the y-axis. So effectively, we are drawing the line x over y equals to 2. Okay, so this point here, 22.71 will be the number of standard maintenance services that Stephen can perform. Right, so we do something similar for Paul. Okay, his x-intercept would be 143, while his y-intercept would be 54. Okay, so we just draw the individual PBC of Paul on GeoGebra first. And then we use the segment function to connect the 2 points here. And then in the session, we'll give you the information. 30.76 will be the number of standard maintenance services that Paul can perform. So we just add up the 2 numbers that I've just identified. Okay, right here. Then we will be able to find out the total number of standard maintenance services that they can produce if they work separately. Okay, so how about question 6? If they work together, they will perform how many percentage more of standard maintenance services than working separately? In other words, we are trying to perform the 4 steps that I've just identified earlier, okay, about find the intersection between the King PBC and the desired ratio. So this means we will start with step 1 to find the x-intercept and the y-intercept of the joint PBC. So the x-intercept simply means that if they only produce brake, what would be the total brake production, right? So it would be 54 plus 143 as the x-intercept, while for y-intercept, it would simply means that what would be the clutch production if they only produce clutch, which is 143 plus 54. Okay, so the x and y-intercepts are both 197. Okay, so we have the points here. Step 2 is to find the king point. So I believe you are able to check on your own that the king point will be 143, 143, where they specializes in producing the good, which they have comparative advantage in production. Okay, so step 3 is to use the segment function to connect the points here. Okay, segment. And we have the PBC here. And finally, step 4 is to draw the desired ratio x over y equals to 2, okay, which is the blue line here. Then the intersection between the PBC and the blue line will give us the total number of standard maintenance services that they can perform if they work together, which is 82.86. So to find the percentage increase, they work together, it is somehow the nu minus O divided by O. The so-called nu is 82.86, the number that they work together, while the so-called O is 53.48, the number they work separately. Okay, the answer to question 5. Okay, so we just use this to calculate the percentage change, which we will have 54.94% of percentage increase. All right, so this is how you can use GeoGebra to help us with this problem. And that's all, and we'll move on to the following one. Please take a look first. Okay, so as you may notice, this one is actually a unit requirement table where it shows the time required for each person to produce 1 unit of the good. Okay, so how can we construct the opportunity relationship here? So let's say for the first person, Adolf, given 8 minutes, obviously Adolf can produce 1 hat or more than 1 tie, right? So it would be 8 divided by 4.71 tie instead of the other way around. Okay, not 4.7 divided by 8. So this is how we can construct the opportunity cost relationship for Adolf. And we do something similar for the remaining persons. Let's say for Ben, it would be 1H equals to 16 divided by 8.42T, and so on. And this is how we can obtain the table here. And as mentioned in the question, the 2 people with the lowest opportunity cost of producing hat will specialize in hat production, so which would be Clara and Desmond. And the remaining 3 persons will be producing tie. So what will be the total number of hats produced? So for Clara, she requires 17 minutes to produce 1 hat. And she has 10 hours to work in total, right? 10 hours is equivalent as 600 minutes. Because for each hat, it requires 17 minutes, and she has 600 minutes in total. So this means that she can produce 600 divided by 17 hats, which is 35.29 hats per day. And for Desmond, he has 10 hours, which is 600 minutes as well. And he requires 15 minutes to produce 1 hat. So Desmond can produce 600 divided by 15, which is 40 hats per day. And if we sum up these 2 numbers, it will be the total number of hats that they can produce. And finally, for tie production, we do something similar. Okay, we just divide 600 minutes by the time required to produce tie for Adolf, Ben, and Eric. And we will have the numbers here. Sum them up, it will be the total number of ties that they can produce. Okay, so this is how we can tackle this problem, and we'll move on to the following one, the last problem in this tutorial. So let's skim through the question first. We have the information that Ricky has the comparative advantage in producing fish, while Andy has the comparative advantage in producing vegetables. And at the point of complete specialization, they will be having 57 fish and 47 vegetables. So this means that all 57 fish must be produced by Ricky, and the remaining 47 vegetables will be produced by Andy. So this is how we can interpret the numbers. And we have the admissible range of term of trade is between 0.5 kg of F per vegetables and 3 kg of fish per vegetable. What will be the vegetable production of Ricky and fish production of Andy if they produce these goods? All right, so how can you interpret the range of term of trade? As we have just reviewed, it's actually the opportunity cost of production for the 2 persons, right? Because the mutually beneficial term of trade must lie strictly between their unit opportunity cost of production. So this actually can be converted like this. as their opportunity cost relationship. So what remains is to map these two opportunity costs back to Ricky and Andy respectively. And we know Andy has a comparative advantage in producing vegetables. This means Andy has a lower opportunity cost in producing vegetables. Okay, so this 1V equals to 0.5 will be mapped to Andy, and the remaining one, 1V equals to 3F, will be mapped to Ricky. So this is how we can obtain the information here. All right, so let's start with Ricky. So 1V is equals to 3F, or equivalency, 1F is 0.33V. To find the number of vegetables that Ricky can produce, okay, we just multiply both sides by 57. Because Ricky can produce 57 kg of fish, and we also have the opportunity cost relationship, 1F equals to 0.33V. Then we know that 57F will be equals to 0.33 multiplied by 57V. And this is how we can obtain the number here. 19. Okay, similarly for Andy, he can produce 47 kg of vegetables, and we have the opportunity cost relationship, 1V equals to 0.5F. Then 47V will be equal to 0.5 times 47F. And this is why we will have the fish production of Andy to be 23.5. Okay, so this is question 27. And question 28, we have the world price of fish at $1 and vegetables is X dollars when they open up to trade. If they only produce fish, what will be the range of values of X? So for this question, we need to check the income at the 3 key points on their PBC, the x-intercept, y-intercept, and the king point. So for the x-intercept, let's say if we are plotting fish on the x-axis, while vegetables on the y-axis, the x-intercept simply means their fish production if they only produce fish, right? Which would be 57 plus 23.5 as the x-intercept, while for the y-intercept, it is 19 plus 47. The vegetable production if they only produce vegetables. Okay, while for the king point, it is simple, 57, 47, the number directly given in the question. Okay, so we are going to check the income at these 3 points. So at the x-intercept, the income would be 80.5 times 1 plus 0 times x, because the price of fish is $1 while the price of vegetables is X dollars. While at the king point, it would be 57 times 1 plus 47 times X. And finally, at the y-intercept, it is 0 times 1 plus 66 times X. And this is how we can obtain the income at these 3 points. If Ricky and Andy only produce fish, then the income at the x-intercept must be greater than the income at the king point and also the income at the y-intercept. So this is how we can get the 2 inequalities here. And solving this compound inequality, we will get x smaller than 0.5, and this is the result of question 28. All right, and finally, question 29. If we have the world price of fish also $1 and the price of vegetables is $2, and Ricky and Andy would like to consume fish and vegetables at a ratio of 0.2 to 1, what would be their consumption of fish and vegetables respectively? So we are going to check which point would give them a high income. Okay, just plug in x equals to 2 and check. And after checking, you will be able to find out that the king point will give them a high income, 151. So the remaining is to use the K method, okay, the method that you should have learned in junior secondary school to help us solve this problem. Okay, so if V is the desired vegetable consumption, then 0.2V will be the desired fish consumption because fish to vegetables is 0.2 to 1, as mentioned in the question. And the equation here is actually to spend what they earn. The left-hand side is the total expenditure on the 2 goods, while the right-hand side is the total income, 151. So the equation can be written as the price of fish multiplied by the quantity of fish plus the price of vegetables multiplied by the quantity of vegetables equals to the total income 151. And here, there's only one unknown V, and we are able to solve it out, 68.64. Finally, to find the desired fish consumption, we just multiplied V by 0.2 to obtain the desired fish consumption. All right, so that's basically what I'd like to discuss in this tutorial today. And by the way, if you have noticed my announcement like 2 days earlier, I've just posted the GeoGebra workshop notes for you to familiarize yourself with the mathematical software or to learn about the functionalities if you're not quite confident with. So you can also go through that notes if you find my pace of teaching GeoGebra in this tutorial too quick. Okay. So anyway, it will be time for the tutorial attendance exercise. So let me give you 6 minutes or so to complete sets D and E. And I'll close the quiz at around 9:26. Thank you. So 2 minutes left for the attendance exercise. Okay, by the way, time is up and I will close the quiz very soon. And thank you very much for joining the tutorial. And again, if you have any question, you can stay behind and ask them. Okay, thank you.